Hello, my name is Ray, and I'm the Ray in the Ray Code. Follow me on Facebook, X, and LinkedIn. In this video, I will give you a complete survey of the creational design pattern known as Singleton. I'll give you a list of benefits you can gain from understanding this design pattern. I'll show you the UML diagram that has been presented by the Gang of Four. I'll give you a code example that you'll be able to get the code from a GitHub site so that you can play around with it yourself. And I will give you a SWOT analysis. I have put timestamps in the margin so you may navigate through the section that gives you the most interest. Give this video a like, subscribe, leave a comment, tell a friend. The Ray Code is awesome. For a developer, understanding the Singleton pattern offers several advantages. Global state management. Singleton allows centralized control over certain system-wide resource configurations. For example, using a Singleton logger ensures all parts of the application write to the same log file. Memory efficient. Only one instance of the object exists, reducing memory usage when multiple instances would otherwise be redundant. Encapsulation. The Singleton class encapsulates its implementation logic, ensuring that other classes don't accidentally create multiple instances. Consistency across the system. By ensuring a single point of control, it eliminates the risk of conflicting states in different parts of the program. Code simplicity. The Singleton pattern simplifies the architecture for scenarios where a single instance is a natural choice. Let's take a look at the UML diagram for the Singleton. Instance is a class operation, a static member function in C++. May be responsible for creating its own instance. Collaboration. Clients access a Singleton instance solely through Singleton's instance operation. Hello, I'm Ray of the Ray Code. Today I will give a code example of the design pattern, the Singleton. The code I will be using will be C++. Tell your friends the Ray Code is awesome. Let's create a class called Singleton. We will start with a .h file. We have the depth for this .h file. We create the class structure. We include IO stream at the top. We have a private static instance pointer. And we have a private constructor to prevent direct instantiation. We have a static method to get a single instance. Now let's have an example method to demonstrate functionality. Now let's do some cleanup, delete, copy constructor, and assignment operator. Next, we go to the CPP side of this Singleton class. In the CPP file, we include the .h file, the Singleton class implementation. We initialize the static member and set up a private constructor. And we have a static method to return a single instance. We have an example method implementation. So let's now create a plain class. We have our traditional defined area. We start off with an include for the IO stream. And for our plain class, we show a simple message. Now let's go over to the CPP side of this plain class. In the CPP file, we include the plain class.h file, and we have a plain class created message, the constructor implementation, example method implementation. Now we go to the main method of our demo in main.cpp. At the top, we include the .h files of a Singleton and plain class. We get the first instance of Singleton. We get another instance of Singleton. We verify that both Singleton instances are the same. We have the message creating plain class instance. We create two separate instances of plain class. Verify that the objects are different. Clean up allocated memory, compile, and we get Singleton instance created. Hello from Singleton. Both Singleton instances are the same object. Creating plain class instance. Plain class instance created. Plain class instance created. Plain class instances are different objects. My name is Ray. Keep coding with a smile. Let's do a SWOT analysis of the Singleton design pattern using C++. S. Strengths. Global access provides a single instance of a class globally, ensuring controlled access to shared resources in C++. Thread safety can be made thread safe using C++ 11 features like standard call once. Resource efficiency reduces memory usage by ensuring only one instance of the class is created. W. Weaknesses. Tight coupling encourages global state, which can reduce modularity and complicate testing. Memory management. Persistent singletons may lead to memory leaks not properly managed. Hidden dependencies. Implicit dependencies on the Singleton instance can make the code harder to understand. O. Opportunities. Configuration management. Commonly used for managing global configuration settings in C++ applications. Logging systems. Centralized access to logging mechanisms, ensuring consistent log writes. Resource sharing. Useful for sharing limited resources like handlers or hardware interfaces. Key. Threats. Overuse risk. Overusing singletons may lead to anti-patterns like God classes. Clustered environments. Managing singleton state across distributed systems is complex. Dependency injection alternative. Dependency injection frameworks offer more modular approaches to resource management. That was my video. I plan to create these videos each week. Follow me on Facebook, X, and LinkedIn. Check out theraycode.org and .com. Leave a comment, subscribe, and like. Be good. The Ray Code is awesome.